So the next topic I'll be discussing is architecture and organization. So architecture, organization, and how computers store and retrieves information. So first, what is architecture and organization? Computer organization and architecture is the study of internal working, structuring, and implementation of a computer system. Architecture in the computer system, same as anywhere else, refers to the externally visual attributes of the system. Externally visual attributes here in computer science mean the way a system is visible to the logic of programs. Organization of a computer system is the way of practical implementation that results in the realization of architectural specifications of a computer system. In more general language, the architecture of a computer system can be considered as a catalog of tools available for any operator using the system, while organization will be the way the system is structured so that all those catalog tools can be used and efficiently. Computer architecture deals with the design of computers, data storage devices, and networking components that stores and run programs, transmit data, and drive interactions between computers across networks and with users. Computer architects use parallelism and various strategies for memory organization to design computing systems with very high performance. Computer requires strong communication between computer scientists and computer engineers since they both focus fundamentally on hardware designs. At its most fundamental level, a computer consists of a control unit in an arithmetic logic unit or the ALU, a memory unit, and input, output or the I/O controllers. The ALU performs simple addition, subtraction, multiplication, division, and logic operations such as OR and AND. The memory stores the programs, instructions, and data. The control unit fetches data and instructions from memory and uses operations of the ALU to carry out those instructions using that data. The control unit and ALU together are referred to as the central processing unit. When an input or output instruction is encountered, the control unit transfers the data between the memory and the designed I/O controller. The operational speed of the CPU primarily determines the speed of the computer as a whole. All of these components, the control unit, the ALU, the memory, and the I/O controllers are realized with transistor circuits. Computers also have another level of memory called a cache. A small, extremely fast compared with the main memory or random access memory, or the RAM, that can be used to store information that is urgently or frequently needed. Current research includes design and algorithms that can predict what data is likely to be needed. Next, preload into it the cache for improved performance. I/O controllers connect the computers to specific input devices such as keyboards and touchscreen displays. For feeding information to the memory, an output device such as printers and displays for transmitting information from the memory of users. Additional I/O controllers connect the computer to a network via ports that provide through which data flows when the computer is connected to the internet. Like the I/O controllers are secondary storage devices such as a disk drive that are slower and have a larger capacity than main or the cache memory disk, are used for maintaining permanent data. They can be either permanently or temporarily attached to the computer in the form of compact discs, a digital video disc, or a memory stick, also called a flash drive. So next, we will describe how computers stored and retrieves information. Using computers, laptops, tablets, and mobile phones concerns storing, retrieving, and transferring information in an efficient way. Data is represented on modern storage media using the binary numeral system. All data storage on storage media, whether that hard disk drives or the HDDs, solid state drives or SSDs, external hard drives, USB flash drives, SD card, can be converted to a string of bits, otherwise known as binary digits. These binary digits have a value of 1 or 0, and the strings can make up photos, documents, audio, and video. A byte is the most common unit of storage and is equal to 8 bits. All data in a computer is stored as a number. For example, letters become numbers. The complete works of Shakespeare's around 1,250 pages in print contains 40 million bits with 1 byte per letter, totaling 5 megabytes or 5 MB. Photographs are converted to a set of numbers that include the location, color, and brightness of each pixel. Whereas convention numbers use 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Binary numbers use 2 digits to represent all possible values. The conventions numbers 0 to 8 translate into binary numbers as 0, 1, 10, 11, 100, 101, 110, 111, and 1000. With binary numbers, any value can be stored as a series of items, which are either true, 10, or false, 0. Binary data is primarily stored in the hard disk drive, or the HDD. The device is made up of spinning disks with magnetic coatings and heads that can both read and write information in the form of magnetic patterns. In addition to hard disk drives, floppy disks and tapes also stored data magnetically. Newer laptops as well as mobile phones, tablets, USB flash drives, and SD cards use solid state or flash storage. With this storage, the binary numbers are instead stored as a series of electrical charge within the NAND flash chips. Because all data is made up of a string of binary numbers, just one number out of place can cause a file to become corrupt. So that's all. Thank you guys.